Yeah, as most of you will have noticed, my calculator on the screen looks a little different to yours. That's because it is the newer version. And clearly Casio finally decided to employ a graphics design engineer because they use colour and some other things. However, the basic functions of mine are still the same as yours. So we should be able to work fine. Alright. Yeah, it's just a new calculator, different face, same functions. Alrighty. Thank you, 11s. A couple of notes before we get started. As far as exam technique goes, you don't have to write this down, or test technique. When it says algebraically, it means you must find the answer without using a calculator. Fairly simple. If it just says find or solve or evaluate, then you're welcome to choose whatever method you like, either algebraically or using your calculator. However, if at the end of the test you get time to go back and check your answers, you're still welcome to check your algebraic answers using your calculator. Does that make sense? So for example, if you discover the roots are 3 and 7 using algebra, you're welcome to go back towards the end of the test and check that using your calculator. Yeah. Alright, so finding roots using technology. There are two modes we can do it in. The first one is equation mode. For me, that's this one here. And for you, I think it's similar. Same square. Yeah? It's A. Yes?
With the algebraic, what if you have like a really odd fraction, like 9.373 over 8.251?
Good question. If, when it asks it for it algebraically, you have an odd fraction or something strange comes up, you can use the run mode of the calculator for the intermediate steps. Say, for example, if it asks you algebraically, and at some point in the algebraic question, it asks you to do 13 times 49, and rather than do that by hand, you're welcome to do little steps like that using the calculator. However, you can't just go straight from start to finish with the calculator. You can use intermediate steps for it. And that's a good question when it comes to quadratic formula, because quadratic formula is quite involved. And if you decide to use quadratic formula, you need to show every step. However, you don't have to do it using mental arithmetic at every step. You can show each individual step, but do little steps of it using the calculator. Alright, now you'll have three options: simultaneous, polynomial, and solver. For our sort of questions, we're aiming for polynomial. Largely we'll be using quadratics. Some of you, have you guys all seen solver before? I think we looked through it quickly in the last topic. Solver is the Hail Mary of the calculator. You shouldn't really be using it unless you're desperate, however it will come up with the answers. Polynomial is the one we're after. Now when you hit F2, it might only come up with degrees 2 and 3. All the way across? Mine only has 2 and 3 on this old calculator. Any of you have the old one? Yeah. Can anyone guess why the older versions have only 2 and 3, whereas the newer ones have 4, 5, 6? No, they still had polynomials back when they produced this. What was that one?
They upgraded.
Yeah, good, they upgraded. But importantly, the reason 2 and 3 are so easy is because there are exact formulas for finding the roots for polynomials of powers 2 and 3. By that I mean quadratics and cubics. So the calculator can enter whatever values you put in for 2 and 3 and will find it exactly. However, for 4, 5 and 6, we don't know the formula for finding the roots exactly. What your calculator essentially has to do is, if that's the x-axis and it crosses, your calculator will take guesses. It will do essentially a Goldilocks search. Oh, too cold, too hot, too cold, too hot, too cold, and so on until it gets close enough till it thinks it's right. Yeah. So it won't be able to find you exact ones with that. You will get very close. The fancy method of this searching is called, it varies on calculator, but probably something along the lines of Newton's method of approximation. It's like an algorithm, it'll flow through. Have you done algorithms in other ways? Oh, hopefully we'll get to do them here because they're cool. But anyway, for us, for our question here, we go 2. Alright, now what it asks for is the coefficients, and up above it has the general form of quadratic equation, ax squared plus bx plus c, and for us we have here is a, the coefficient of x squared, b, the coefficient of x, and c is our constant. And when we enter these in, it's very important we enter in the signs as well. So the coefficient of x squared for us here is 1, for x is negative 3, and for the constant is negative 22, and the signs must go in also. And then we click solve, and it will come out with 2 solutions. And because our calculators are nice and new, they should give us exact solutions. And it shouldn't surprise us when it's 3 plus root 97 over 2, and then what will the other one be at a guess? Yeah, good. 3 minus root 97 over 2, because it's come from the quadratic formula. Alright? Notice how the general form of the quadratic up here, can you see that? Yeah? Is equal to 0. So essentially, if you were given an equation where it was 3x squared take 2x equals 27, your first step is to bring the 27 over and make the other side equal to 0. And that has to happen before you put it in the calculator. Alright? Now, using our second technique is graphics mode. And I like graphics mode far more because it actually shows you what's happening. It doesn't all happen magically behind the scenes like it does in equation mode. And graphics mode is 5 for most calculators. Mine's all nice and coloured. Now, here you have a couple of options. So we're doing the second question. This one here. What we can do is either get everything on one side, make it equal to 0, or we type it in as 2 separate equations. So let's pretend we don't want to go through the algebra. We can just treat this side as y1 and this side as y2. So in our graph mode, we enter x to the power of 2 take 4x as y1, and then as y2, oh god, we go 21 plus 2x. Now, what else do we need to check before we're actually going to graph it? Yeah, it's worth having a look at view window. So Shift F3 will get you view window. And generally, I go for standard. So you hit F3 again. Standard's a good place to start, especially when looking at simple quadratics. There's no guarantee that both the intersections will occur in that search area. But if need be, we can always zoom out later on. And now we ask it to draw. So clearly, we haven't got the search area right because we haven't got intersections yet. So what might we adjust our search area to, or the view screen to? Up. So again, Shift, View Window, and X and Y. The X ones looked okay, but the Y, our max, let's make it 40. And try that again. Draw. Yeah? Your calculator's all doing similar things, following?
Yeah.
Alright, now, how do we find the 2 intersections? We go G-solve, which is an excellent place to start, and then hit F5, again, intersections. And it will ask us to, if there were more than 2 graphs on there, it would ask you to confirm which intersections you actually mean, but this one it's just finding them for you. So we have x equals minus 2.47. Thank you. Oh yeah, I can't round. If you've noticed this, I will get it wrong every time. And across 8.48. Alright. Now, let's see what happens if we did go through the algebraic step and got one side equal to 0. Moving everything from the right to the left, we would have x squared take 6x take 21 equals 0. Now let's put that in as F3. So x squared take 6x 821. The green's hard to see, isn't it? No, it's okay. So, it shouldn't come as a surprise to us that our green line is cutting the x-axis directly underneath the intersection of the other two. Does that make sense? So if we're finding solutions for x, we can either find the intersection of the two lines, or we can find where the green line, the resultant quadratic, is equal to 0, where the roots are. And to find the roots of the quadratic, we hit gsolve and click root. And here it will ask us which one we're talking about. Either the one that's flashing, we don't want that, or that one, but we do want that one. I'm not sure if yours flashes or not. No. Then there will be an indicator indicating which one it is. Incidentally, if you want this to play with, it's a 90-day free trial that's dead easy to download. Anyway, just thought I'd mention that. Huh? I haven't tested that yet, but I haven't run out. I'll tell you in about, 89 more days when this one runs out. I downloaded it this morning. So there's our first root, is negative 2.48, which is no surprise, and the next one across, 8.48. So they're the same answers, just two different ways of getting about it. I like watching the two graphs intersect, so I like the first method. And because it doesn't rely on any algebra to rearrange it. Having said that, you're welcome to rearrange. Alrighty, so any questions using the technology? No? It does make it nice and easy and fun for us, and quick.
When I do the root thing, it doesn't let me get the roots until...
Press up and down until...
Yeah, I do, but it doesn't go with it. It's just those two.
Yeah. So see that marker there? Yeah. And there. See how it's y3 now? Why is it 6 squared? Squared instead of x. But then you'd hit execute and it would find the 2. Because yours are different because you don't have the x. That's fine. Alrighty, so can you go to page 32 and do the questions there? So, page 32, exercise 1E. There's only 2 questions, but do them all.